Now let's examine some rules, or what we call the laws of probability. We'll use a Venn diagram to assist with the explanation of these probability laws. The Venn diagram seen here represents two subjects chosen by a group of 20 students. Accounts represented by the letter A and biology represented by the letter B. A student is randomly selected. What is the probability that the student choose accounts? To get this answer, we'll need to focus on the number of students in the circle representing accounts. That's 9 and 3, which is 12, from a total of 20 students. So the probability of A is 12 over 20. What is the probability that a student choose biology? To get this answer, we'll need to focus on the number of students in the circle representing biology. That's 8, and 3, which is 11, from a total of 20 students. So the probability of B is 11 over 20. If we want the probability of the union of both sets, we'll need to add the values in both sets. That's 9, 3, and 8, which is 20. So the probability of A union B, which by the way is the same as probability of A or B, is 20 out of a total of 20 students, which simplify to 1. Notice when you were counting the number of students in the sets A and B, the number in the intersection 3 was added twice, so we can see that the probability of A union B, which is 1, is equal to the probability of A plus the probability of B minus the probability of the intersection, since the intersection was added twice. The rule is basically telling us that when calculating the probability of A or B, we add their probabilities, but subtract the intersection or the overlap to avoid double counting. Here is another example where we can apply the addition rule. The table shows the results of a political poll for a sample of 50 persons. What is the probability that a person chosen from the sample is a Republican or a female? Using the addition law, the probability of Republican or female is the probability of Republican plus the probability of female minus the probability of Republican and female. There is a total of 26 Republicans out of the grand total of 50, while there is a total of 25 females out of the sample total of 50. 10 persons are females who are also Republicans, so the probability that a person is both a female and a Republican is 10 over 50. Notice that the 10 had to be subtracted since it was added twice when we calculated the probabilities for female and Republican separately. So the probability that a person in the survey is a female or a Republican is 41 over 50, or 0.82, or 82%. Two events are said to be mutually exclusive if they cannot occur at the same time. For example, if we roll a dice and let A be the event that the dice shows an odd number, and B be the event that the dice shows an even number, we would see that the sets are disjointed and have no intersection, since a number cannot be both odd and even at the same time. Hence, if two sets A and B are mutually exclusive, then the probability of A intersect B is 0. Here is another example. A jar contains 4 blue candies, 5 red candies, and 1 yellow candy. A candy is randomly drawn from the jar. What is the probability that the candy drawn is either red or yellow? To find the solution, we'll use the addition rule. The probability of red or yellow is the probability of red, plus the probability of yellow only, since there is no intersection. Red and yellow candies are mutually exclusive, since none of the candies have both colors. The probability of red is 5/10, while the probability of yellow is 1/10. So the probability of drawing a red or yellow candy is 6/10 or 60%. In the next video, we'll look at the multiplication rule and independent events. Don't forget to like, subscribe, and tap that bell for more exciting lessons. See you soon!